So I've already talked about how the derivative at a point x gives you the gradient of the tangent at that point. Now what we're going to do is use that fact to derive an official formula for the gradient for any function, and this is the definition of the gradient. And then maybe in future videos I can refer back to this to show you where some of the standard results we're going to state come from. As you can see, if we take a point x and then a point x plus h, so h is just some extra amount, okay, that we've added on, we get a new point here, and the line between these points is, and then the y value of the point at x is f of x, and then the y value here is the function applied to x plus h, okay? And this is if, of course, y is equal to f of x. With this our y-axis and our x coordinate here, okay? So the gradient of this line, the slope of this line, is equal to, so the gradient of, we'll call it a chord, I guess, is equal to f of x plus h, the change in y over the change in x, so f of x plus h minus f of x over x plus h minus x. That's equal to f of x plus h minus f of x over h. And remember the derivative is equal to the gradient of the tangent of the point x. So how can we use what we have here to get the tangent of the point x? Well, as h comes in closer and closer and closer, okay, and we get different points, alright, and it keeps coming, you can see that the line between the that we get gets closer and closer and closer to the tangent. So the tangent, the gradient of the tangent, is equal to the limit of this expression here as h tends to 0. So f dash of x is equal to the limit h tends to 0 of f of x plus h minus f of x over h. And if you have any experience with limits, you might think, well, this is an issue here, because aren't we divided by 0? Well, no, for a start, because we're taking a limit of h tends to 0, which is slightly different. And also, this f of x plus h has h dependent. So when we because remember this will be a specific function, we can actually get some nice rearrangements going, and we end up without h on the bottom, okay, necessarily. So yeah, that's important to remember. There are, of course, times where this limit is not well defined, and when we can't define derivatives, and maybe we'll see some examples of that. But for a lot of our simple functions, polynomials, exponentials, logarithms, trigonometric functions, you can find the derivative, so that's nice. Yeah, I think when I was studying, you didn't have to know this definition, but it was nice to know it. I think nowadays on the specification, you are supposed to know this, so make sure you remember it. But I think it's a good thing to learn anyway, because when you're working with derivatives, it's nice to know where a lot of this stuff comes from. Yeah, so if you didn't understand anything in this definition, let me know in the comments and I'll try as best I can. If you did enjoy the video, please leave it a like, the support's much appreciated, and subscribe to the channel for more A-level maths content. Thank you for watching. See you in the next one.